I'm Professor Peter Sadler. I'm Professor of Chemistry at the University of Warwick. My area of research is concerned with inorganic chemistry and its application to biology and medicine. So I'm optimistic that there is an enormous amount of information in this field that's yet to be discovered, that there are many elements that we just don't understand whether they're essential for life or not. In fact, the whole of the periodic table is available for research and discovery, and we're at the beginnings of the research and discovery. We know, for example, there are a lot of metal ions in the brain. There's zinc, there's manganese, there's copper, and so on. But we don't understand really what they're doing there. We don't understand if the chemistry goes wrong in the brain, how they contribute to disease. We don't understand how to control them, for example. And there are many elements like nickel, like tin, like chromium that may be essential or maybe not. And I keep saying to people, this is 2010. We know the sequence of the human genome. We know it contains 3,000 million letters, but we don't know whether some of these elements are essential or not. We can't read the genome yet to determine whether they're essential or not. Maybe we never will be able to. So there's an enormous amount of information there that we don't understand, of research to be done, that I think for the young people should make them very optimistic about the future in terms of understanding the way that living organisms work, understanding how to treat disease, understanding the origins of disease, and so on, looking at the inorganic aspects of life.
Okay, and what was it that made you want to contribute to the project? What do you think was exciting about it?
I think really just to put across these views that everything is not well understood. There are many things we don't understand, and for example, as I've said, having the sequence of the human genome is very important, but it's not the total answer. It doesn't tell us everything. If we want to culture cells, to grow stem cells, etc., what elements of the periodic table are we feeding those cells? Many of them we're just leaving it to chance. We're not controlling how much of a lot of elements we put in there. Even arsenic, for example, is in marine organisms, in flatfish, in lobsters and so on. It's in the natural environment. It's in the food that we eat. At some low levels, who knows, it might be doing something important. And we're even using arsenic in medicine as a first-line drug for certain types of leukemia, for example. I think it's making people aware of this other side of biology, this other side of medicine that made me want to contribute to the book.